Good evening, class. The last class what we have discussed, aldol condensation and Cannizzaro reactions, right? Cross, aldol and different types of reactions. So we learned actually chemical properties of aldehyde and ketone. Right? Chemical properties of aldehyde and ketone. And aldehyde and ketone combinedly known as carbonyl compounds. We have seen so many different reactions. Today we are going to discuss about the aldol condensation and Cannizzaro reaction. These are very important reactions for your board exam as well as competitive exams like JEE Mains and NEET. So first we'll discuss aldol reaction. What is aldol reaction? What is the meaning of the word aldol? There is two functional group combines, right? There is two functional group. Look at the word ald, A-L-D. It is basically denoting aldehyde. Aldehyde. And what's the meaning of OL? It's denoting the functional group alcohol. Alcohol. Right? So aldol means the molecule which contain both the functional group like aldehyde as well as alcohol. What is an aldol reaction? So just consider any carbonyl compounds having at least one alpha hydrogen. So look at this molecule. This is your carbonyl compound and this is your carbonyl functional group. And you know, functional group connected carbon is known as what? Alpha carbon. This is your alpha carbon. And this alpha carbon has some hydrogens. That hydrogens are known as alpha hydrogen. So these hydrogens, how many alpha hydrogens are there? 3 alpha hydrogens are there. There are 3 alpha hydrogens. And alpha hydrogens are acidic in nature. These alpha hydrogens are acidic in nature. Now why these alpha hydrogens are acidic in nature? So let's discuss why we are considering these alpha hydrogens are acidic in nature. Suppose any example, just consider acetaldehyde, and we have one base, any base. This base will abstract the alpha hydrogen, make it 2. This base will abstract this alpha hydrogen, and what will you get? CH2, C double bond O and H, right? Yeah, this one, and there is a negative sign because this OH minus abstracted your hydrogen, and you know acidic hydrogens are nothing but hydrogen H plus, proton. So proton is abstract by this OH minus. Look at this negative sign. This negative charge is stabilized through resonance phenomena. This negative charge, this is nothing but conjugate base. And this conjugate base is stabilized through resonance. Right? And this form, what we call this form? There is a double bond. Double bond means alkene. So we call it in, and it's an alcohol group, right? OH. So it's all, and whenever we write negative sign, we call ATE. We use ATE suffix. It's your ATE. So this molecule is known as enolate. This molecule is known as enolate. So why your alpha hydrogens are acidic in nature? Because the conjugate base is stabilized by resonance, right? That's why these alpha hydrogens are considered as acidic in nature. Because of this acidic nature, it gives aldol condensation. Now what's aldol condensation? Our main reaction was aldol condensation, right? This is clear? Is it clear? Yes or no? Good. Come to the aldol reaction. Aldol. Any carbonyl compounds reacting with dilute base like NaOH, KOH having alpha hydrogen. So first is carbonyl compound must have at least one alpha hydrogen. This is the first condition of aldol condensation. This is the first condition of aldol condensation, that we must have at least one alpha hydrogen. Clear? And next is carbonyl compounds having alpha hydrogen. This is your alpha carbon, and if this carbonyl compound is reacting in presence of dilute NaOH or KOH, potassium hydroxide or sodium hydroxide, then what will happen? Then it will show your aldol reaction, and you will get the final product, that is aldol condensation product, alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. So it follows two-step mechanism. This reaction follows two-step mechanism. The first step of the mechanism is formation of enolate ion. The second step is combination of one carbonyl group with another carbonyl group. You can say condensation of one carbonyl group with another. In the first step, there is the formation of enolate ion, and in the second step, one carbonyl compound will attack on the another carbonyl compound, and they will join together. So there are two main steps in this mechanism. Now look here how we can discuss the mechanism and how this mechanism looks like. So you have any carbonyl compounds having alpha hydrogen, and there is a base OH minus. What this base will do? This base will abstract the acidic hydrogen. So this base will abstract this acidic hydrogen, and you will get this molecule, right? CH2 negative. Now this CH2 negative can be stabilized through resonance, and you will get enolate ion. This is your enolate. Now you form the enolate ion. This is the first step of the mechanism. In the second step, addition of one carbonyl compound with another, right? Combination of two carbonyl compounds. So you have this enolate ion. We can consider the first one. Yes, come. And in the reaction vessel, there are so many molecules of your acetaldehyde. So another acetaldehyde molecules we are considering here. Okay. Now you know oxygen is more electronegative than carbon, so it will be a partial negative charge. This will partial positive charge. Next, what will happen? This is your positive center. This is your positive center, and you have one negative charge, nucleophile. So what this nucleophile will do? This nucleophile will attack on this positive center, and you know that carbon can form maximum of 4 bonds, right? So it is forming a new bond. What you have to do? You have to break an old bond. And which bond will break? Pi bond, because pi bond is weaker than sigma. So this pi bond will break. This pi bond will break. Next, now join this two. How to join? First write this one, this molecule. It's very easy. CH3, C and O minus, and you have hydrogen. Next, this carbon joined with this CH2, COH. This is your second step when you combine all the two molecules of aldehyde or either ketone, whatever you have taken. Right, this is the condensed product. Means two carbonyl compounds condensed together. Next, do the workup. You can use any dilute HCl. We do workup just to get the neutral product. Just to get the neutral product. Because it's ionic product. We don't need it. We need neutral product. So this negative charge will abstract this hydrogen, acidic hydrogen, and you will get the neutral product CH3, CH, OH, and then CH2, COH. This one. Right. This is your alpha carbon and this is your beta carbon. This is your beta hydroxy aldehyde. This is your beta hydroxy aldehyde. Now, is there any chance? So you have combined both, right? You combined both the reactions. What will happen? You know, they are bad boys. They have to complain their parents. So this is the complaint. What you are giving? Heat. Right? You are complaining about the molecules. You are giving heat. Because of this heat, what will happen? Is there any possibility of removal of water? Yes. Yes. So here alpha hydrogen and OH. Because of this heat, what will happen? There will be the removal of water. Removal of water takes place and finally you will get the product CH3, CH, double bond, CH and C double bond OH. Right? What's the name of this product? What is the name of this product? This is your alpha carbon, this is your beta. Alpha, beta, unsaturated carbonyl compound. Unsaturated carbonyl compound. Write down. Alpha, beta, unsaturated carbonyl compound, right? I hope you understood both the steps of the mechanism. In the first step, what's the name of the first step? Formation of enolate ion. And second step, condensation of one carbonyl with another one, right? So in the first step, base abstract the alpha hydrogen and you got nucleophile, and that nucleophile is stabilized through resonance. Then that nucleophile attacks what? To another molecule of the aldehyde, and both the molecules combine together, and we have done the workup just to get neutral product. And if there is a chance that you can remove water because it's a basic medium, okay, and if you have heat, just remove the water molecules and you will get the final product, aldol condensation product, that is alpha beta unsaturated carbonyl compound. Is it clear? Good. Now you just try one molecule. So what do you think? This one will give aldol condensation or not? This is your carbonyl compound, right? This one will give, this one will undergo carbonyl like aldol reactions or not? No. Why? No alpha hydrogen. There is no alpha hydrogen, right? There is no alpha hydrogen. No alpha hydrogen. So this molecule will not give aldol. What's about this? This one? This one will undergo alpha like aldol condensation or not? What do you think? This is your functional group carbonyl and this is alpha carbon. Is there any alpha hydrogen? No. No alpha hydrogen here also. No alpha hydrogen. So this one will also does not undergo aldol condensation. What's about this? This is your benzaldehyde. Can benzaldehyde undergo alpha aldol condensation? Is there any possibility? No, because this is your carbonyl compound and this is your alpha carbon, and all four bonds of this carbon is already there, so there is no alpha hydrogen. Here also no alpha hydrogen. What's about this? How many alpha hydrogens are there? How many alpha hydrogens? 6. This is alpha carbon, this is also alpha carbon. So there are 6 alpha hydrogens. This one will undergo aldol condensation or not? This one? Yes, because there is alpha hydrogen, so this one will undergo your aldol condensation. So you have to try this one. I'm giving you the reaction, just try this. What is the name of this molecule? What is the name of this molecule? Acetone. So you can use like in Hindi, don't talk to me in CH3COCH3. Don't talk to me in CH3COCH3 means मेरे से इस एसीटोन में बात मत करो. Don't talk to me in CH3COCH3. This is your acetone. You can use the chemistry in your real life. It's very funny and amazing. Okay, acetone. Now you can say your friend, don't talk to me in CH3COCH3. Okay. Do aldol reactions and you have one base OH minus. What will be the product? Tell me. Draw the final product of this molecule. You have acetone, right? This is your acetone and base is there, alpha alpha. Both side you have alpha hydrogen. You can consider anyone, there is no confusion in this case. Okay, and later if both side alpha hydrogens are there, then there are some factor which one we should choose, that we will discuss later. Here this alpha hydrogen, suppose we have choose, so this OH will abstract this hydrogen, right, and it will form enolate ion. It will form an enolate ion, CH2 CO CH3, and negative charge will be there, and this negative charge is stabilized through resonance. It will stabilize through resonance. This is first step. What's the name of this molecule? It's enolate. What is the name? Enolate. Enolate. So this is the first step of the mechanism. Second step, combination of two. Combination of two molecules. So you have the molecule, first one, this, and this one will combine with another molecule of acetone, right? They will combine with another molecule of acetone. So what will be the product? 1 minute. Yes, tell me. So what happened? This negative will attack on this carbonyl center, because carbonyl has positive charge. It's a positive center, and you know nucleophiles is nothing but nucleus positive loving species. So nucleophile will attack on this carbon and they will combine together. How to write? Write down this first, CH3 CO, and write this CH3 in the bottom side, and now join that part. So you have CH2 CO and CH3, this one. What's the next step? Next step, what we have to do? What's the next step? It's your workup. Dilute HCl. Where is the negative sign? Oh, okay. This is your negative. So you will get the neutral product, CH3 COH CH2 CO CH3. Is there any possibility that you can remove water in this case? So this is your alpha, right? This is your alpha and this is beta. Is there any possibility? Possibility is there? Yes. So remove water. Hit. Just remove. There is alpha hydrogen here. Remove the water. What will be the final product? Your final product is will be CH3 C double bond CH3 CH and then CO CH3, right? This is your final product, and this is again you can say alpha beta unsaturated carbonyl compound. What we can say? Alpha beta unsaturated carbonyl compound, right? Write down. So you understood what is aldol reaction And there is various type of aldol reaction, aldol condensation. What are the types? So there are three aldol type. Aldol reaction is three types. Aldol condensation. How many? Three. The first one is known as simple aldol reaction. Simple aldol reaction. Simple. Second one is known as cross aldol. Cross aldol, or you can say mixed aldol, or you can say mixed aldol. And third one is your intramolecular aldol condensation. Intramolecular aldol condensation. Now in this case, the first one, in case of simple aldol condensation, both the molecules, like only one carbonyl compound will undergo aldol condensation. Suppose we have taken CH3 COH, acetaldehyde. So in this case, this acetaldehyde, after formation of enolate ion, this will react with same molecule of acetaldehyde, or normally you can say two molecules of same carbonyl compound. Two molecules of same carbonyl compound. So this is known as simple aldol reaction. In case of simple aldol reaction, we consider same type of carbonyl compound. Clear? But in case of cross aldol, we consider two different carbonyl compound. Two different carbonyl compound. One and plus, you can consider anything else. This one. So there both are different. This is called cross, or you can say mixed. Mixed means, you know, mixing of two, right? Two different things. Now what about is this intramolecular? Intra means same or different? Intra means same. Intra means same. So if in a functional, in a long chain hydrocarbon, there are two or more than two. Okay, two or more than two carbonyl compounds are present. Then it can show your what? What it can show? Tell me. It can show intramolecular aldol reaction. How many carbonyl compounds are there in this molecule? How many? Two. Right? Two carbonyl compounds are there. One is your ketone, another is your aldehyde. So in one molecule, two carbonyl compounds are there and they will do the reaction. This is called intramolecular. Intra means same. In a same molecule, the reaction will happen. We don't need two molecules. Here in case of simple, we have used two. In case of cross and mixed aldol condensation also, we need to use two. But in case of intramolecular, we need only one molecule. Okay. So simple aldol condensation we have already seen. Okay. Next is your cross or mixed. Cross aldol or mixed aldol. What is that? We'll see. Is this clear? Any confusion? Cross aldol. Put heading cross aldol condensation. Cross aldol condensation. We need two molecules and both should be different. Both should be different. So suppose we have taken one is your acetaldehyde and another is acetone. In case of cross aldol reaction, number of products are very important. Like how many number of products can be formed, that is the more important part as compared to the mechanism part. Mechanism part is same as it is, but here the main thing is how many number of products can be formed. Because what will happen here, this molecule has alpha hydrogen, both have alpha hydrogen. This is your alpha, this is also alpha. So this one has 3 alpha hydrogen and this molecule has 6 alpha hydrogen. Both have alpha hydrogen, and you know alpha hydrogens are acidic in nature. So this molecule can form enolate, this can also form enolate, right? So there are more number of probability that anyone can form enolate, right? So suppose this is forming enolate. In the first case, this ion is forming enolate, okay? This is forming enolate. Now this is suppose A, okay? This A can react with react with another molecule of A. One possibility, this acetaldehyde can react with another molecule of acetaldehyde, because there are so many acetaldehyde in your reaction vessel. It's not like that I have written only one, it means one. No, we have done the reaction in a beaker or any RB, okay? There are so many molecules. It's not only one molecules can do the reaction, no. So first possibility, this A can react with the A, same. Another is, consider this part as B. So this A can react with B, right? How many products? 2. Same, if this B is forming enolate, now B is forming enolate. B is forming enolate. So this B can also react with another B. And what's the other condition? What's the another condition? This B, this whole molecule after formation of enolate ion, it can react with A. So there is one more possibility, right? So total number of products are how many? Total number of products, your A is giving how many products? How many? 2. B is giving how many products? 2. So total products are, total number of products, how many? Total products are 4. 2 from A and 2 from B. So you understood how many products you need to draw? 4. You have to draw how many products? 4 products. So I am giving you, just consider this example and draw all the 4 products. Draw all the 4 products. Right? You have acetaldehyde, and so first consider the acetaldehyde, and this acetaldehyde is forming enolate, okay? CH2CO, right? Yes or no? And in another case we have taken acetone, and in this case acetone is giving you enolate. So you have total 2 enolate formation. Now first consider the first one. So So there is two possibility. Possibility number one, that this molecule can react with the same molecule of this acetaldehyde. The another possibility, that this acetaldehyde enolate can react with the ketone acetone. Right? Then what will happen? What will be the product in the first case and the second case? Do it. You know, oxygen is more electronegative than carbon. So this negative will attack here as well as in the second case. Draw the final products. So do workup, and there is a chance of removing water. So your final product will be this CH3 CH double bond CHCOH. This is your final product. Just match with your product, whether same or different, and in this case you will get the product CH3 double bond CH. Did you get the same product? Did you get the same product or different? Same or different? Same, right? Good. Next, what is the next possibility we can consider? We can consider the second enolate, right? We can consider the second enolate. This you understood, right? Good. So we can consider the second enolate. What is the second enolate we have? This one. This can react with similar molecule of this. And another possibility, that this can react with acetaldehyde, right? Tell me the product. You can also draw the direct product. Look at here, how to draw the direct product. First, you just show it negative, positive, negative, positive. This attack you just show. So this will help you how to draw the product. Now, write down this as it is. Write down this CH3 and C. This step, you know, after removing of water, after removal of water, this O will not be there, right? So there will be possibility of double bond, and there is a CH3. Done. Now attach this double bond with this. You cannot write CH2 because you have to remove water also. So water H from that place and OH from here, and you will get the product. Okay, CH, then you have CO, CH3, right? And in this case, draw this one first, CH3. This O will not be there, right? Only double bond is there, and you have hydrogen also joined with that carbon. CH, CO, CH3. Now match. Is there any similar product out of all four? Is there any similar product out of all four? Check the last two. All are different, right? All are different products. So in case of cross aldol, if both the carbonyl has alpha hydrogen, then the total number of products are 4, right? Total number of products are 4. But we can have one more condition. If only one carbonyl molecule have alpha hydrogen and another does not have, then how many number of products will we get? You see, this is clear? Is this clear? Good. So consider this one. Is there any alpha hydrogen in this molecule? How many alpha hydrogen? No alpha hydrogen, right? There is no alpha carbon. So how can we have alpha hydrogen? So there is no alpha hydrogen. And in this molecule, 3 alpha hydrogen. And you know, if you don't have alpha hydrogen, can we get enolate? No, we cannot get enolate ion. So there is no enolate formation. No enolate. It means it cannot attack. This cannot attack, right? So enolate formation only happen here. This person will give enolate. This person will give enolate, and suppose this is called A. This is A. So this A can react with another molecule of A, and this A can react with this formaldehyde. This you can consider as B molecule. This is your A. It can react with B. How many products now? Total number of products are 2. So in this case, if you have only alpha hydrogen in one carbonyl compound, on that case you have 2 products, right? In case of simple aldol condensation, we have only 1 product, right? And in case of cross aldol reaction, if both the carbonyl have alpha hydrogen, then total number of products are 4. And the last case, if one carbonyl compound has alpha hydrogen and another does not have, then 2 products. You understood? Okay, so you can do the reaction. No formation of enolate. This side enolate formation is there. So you do it by yourself and make a chart. Number of products. So this is aldol reaction, aldol type, and this is number of products. Number of products. First type is simple aldol. How many product? How many product? 1. And cross aldol. Cross aldol. And in this case, both carbonyl compound has alpha hydrogen. In this case, how many products? If both the carbonyl compounds have alpha hydrogen, then how many products? How many total? 4 products. And in the last case, if you have alpha hydrogen, it's also cross aldol. It is also called cross aldol, but only one carbonyl compound, only one carbonyl has alpha hydrogen. In this case, how many products, sir? 2 products. Okay, make this table, and you know very well how to draw the products. Like, yes. So we have one more, the last one, intramolecular aldol reaction. intramolecular aldol. This is clear? Understood? Good. Last is intramolecular aldol. Intramolecular aldol. So consider having alpha hydrogen. Yes or no? This is your alpha carbon and this is your also alpha carbon. Now you have to choose which alpha we need. So suppose this alpha hydrogen we are taking. So this will form enolate, negative ion will come here, negative charge. Now this negative will attack on this positive center. How many number of member ring? 1, 2, 3, 4. You are getting 4 member ring. And if I'll consider this alpha, then how many member ring we are getting? 1, 2, 3, 4. In both the case we are getting same. Okay, we just so both alpha are same. We can consider anyone. Just consider this one. Base is there. Abstract this hydrogen. What will be the product? Right? Negative charge will come here. Now what we can do? This one will attack on this carbon and you will get this. Always remember one thing, in case of cyclization reaction, when the open chain becomes cyclic, please write the number of each carbon. So this is your 1, 2, 3, 4, 5. There are 5 carbon. Here also mention the numbering. 1, 2, 3, 4, 5. So who are forming the ring? 2 is forming the ring with 5. How many member ring? 1, 2, 3, 4. So there is a 4 member ring. 4 member ring. And 2 and 5 is forming the ring. 2, 3, 4, 5. And 1 is your outside. Right? So with 2, this part is attached. Yes or no? With 2, this part is attached. So write down as it is. Next, in 5, look at the 5. In 5, you have CO bond, right? In 5, you have CO minus bond. So this is your ring. This your intramolecular aldol condensation is a type of cyclization reaction when open chain converted into cyclic ring. Now next step is workup. So after workup you will get this product. This one, is there any possibility of removing water? This is your alpha carbon, right? This is your alpha. This is your beta. Yes, we can remove water. So just remove water. You will get the final product. You will get the final product, this. Right? Here you can see there is a formation of 4 member ring. There is a formation of 4 member ring. If you have a case where there is two possibility. One is formation of 4 member, another is formation of 5 member. Then what you need to choose? 5 member, because the stability of ring strand is like this. 3 member is less stable than 4, 5 membered, and then 6 membered. Sorry, this is your 5 membered ring, and then you have 6 member ring. It is just because of the ring strain. In case of 3 membered ring, the bond angle is 60 degree, but in case of 6 member ring, the bond angle is 120 degree. Here the flexibility is there, so the atom of carbon can easily survive. Okay. In some cases what happened, 5 membered is more preferred, more stable than 6 membered. That is very rare cases, so no need to worry for that. So you understood this one? Okay. Next, try one more. Aldol. Okay. Yes, try this one. What will be the product? Tell me. First, assign the alpha hydrogens, then only you can decide which alpha hydrogen you need to choose. So this is alpha 1, this is also alpha, this is also alpha, this is also alpha. Okay. If I'll choose this alpha hydrogen, this one, then you will get negative charge here, right? And this negative charge will attack on this carbon. How many member ring you are getting? 1, 2, 3, 4, 5, 6. Yeah, 6 member. From this center you are getting 6 member ring. Good. What's about this center? You will get negative charge. 1, 2, 3, 4 member. Not possible, right? From here you are getting 4 member. What's about this? Same. 1, 2, 3, 4. From this position also you are getting 4 member ring. And in this case, how many member ring you are getting? 6. 1, 2, 3, 4, 5, 6. So you are getting 6 member. What will be your product? So we don't consider the 4 member because we have better option, and everyone choose better option, right? In all cases, right? So you can consider this alpha as well as this alpha. Okay, and in both the case you will get different products. So first choose this one, this alpha, and then this. There is also one more thing. First choose this first one, this one. According to this, draw the product, and then this one. So here you will get negative sign, right? This negative will attack on this position. You will get 6 member ring. Give the numbering from here 1, 2, 3, 4, 5, 6, 7, 8. Draw a 6-member ring and give numbering 1, 2, 3, 4, 5, 6. And second position, what do you have? Second position, double bond, right? And in sixth position, yeah, single bond. No, in second position you have double bond. Okay. And sixth position you have single bond. And sixth position you have this part also, ethyl part, right? So this is negative. What is the next step? Workup. Do the workup, you will get. Is there any possibility in this case to remove water? Is there any possibility? Yes. I don't think. Let's see. Yeah, this is your alpha, this is your beta. Yes, there is a possibility of removing water. Minus H2O. What will be the final product? This is your final product, right? That is your final product. You can try this one also. So this you do by yourself. So that's it for today. So what we have discussed? Aldol condensation, right? And next class we'll see Cannizzaro. And the special thing, the Cannizzaro and aldols are two opposite. Means here we need alpha hydrogen, there we don't need alpha hydrogen. Okay. Here at least one alpha hydrogen should be there. On that case, there should not be any alpha hydrogen. So what we have discussed? Aldol condensation. Aldol is the mixture of two functional group, aldehyde and alcohol. And in aldol reaction, any carbonyl compounds react with dilute base and it forms enolate, and that enolate combined with another molecule of carbonyl compounds. Means the mechanism contain how many steps? 2 steps. What's the name of the first step? Formation of enolate. Second step is condensation of 2 carbonyl molecules. And in aldol condensation we have seen 3 types. What are the types? Simple aldol condensation, and then cross or mixed aldol condensation, and the last one is intramolecular aldol condensation. Okay, thank you class.